Hello students, today we're going to be doing some area applications for the HVAC program. This worksheet you can print it out or you can just take notes on another sheet of paper. Our first question is the area of scrap, the shaded region, that would result from cutting the parallelogram out of this trapezoid. And it says your answers in square centimeters. I'm going to show you a trick here at the end that will convert that. But we need to start by finding the area of the whole piece. So the whole piece is a trapezoid. And our formula for a trapezoid, which you can find on your formula sheet, is 1/2 of the height times B1 plus B2, and the B1, B2 refer to the top and the bottom of that trapezoid. So we would have half of the height is 450, and B1 and B2 is 720 and 862. Again, we're talking about the trapezoid on the outside, the whole thing. So if we plop that into our calculator, making sure that we put the parentheses in there, our area of our trapezoid is 355,950, and these are millimeters squared. So this number seems very large because each millimeter is tiny, so therefore there are more of them. And now let's do the area of the parallelogram. And again, you can get this formula from your formula sheet. The base times the height for the parallelogram. That's this piece inside of here. The base would be 630. The height would be 275. And if we multiply those together, we get 173,250 millimeters squared. Because that parallelogram is being cut out of the trapezoid, we would subtract those two areas. And when we subtract them, we get an area of 182,700 millimeters squared. But our question asks for centimeters squared. So we need to do a conversion. Most of you will not know off the top of your head that there are 100 millimeters squared and 1 centimeter squared, okay? But, so you could use that if you knew it. It is more likely to know that you would know that there's 10 millimeters and a centimeter. It's lacking the squared part of it, but we can use that. If we were going from millimeters to centimeters, we'd be dividing by 10, and because it's squared, here's the trick, that if you divide by 10 twice, it'll still do the conversion just like normal. Same thing that if it was cubed, you could divide by 10 3 times. But if I do that, it leaves us with 1,827 centimeters squared. That would be in that shaded region. Okay, there's your first problem. Let's look at our second problem here. This is a sheet metal container that's to be covered with rust-proof coating. How much surface area would you consider if the entire container is to be coated inside and out? So there's a couple different ways to do this, But the one thing that is true is that we would have to find the area of each one of these pieces and add them all together. So if we start with these two sides, they are exactly the same. They are rectangles. So we could do 50.3 times 12.5. And then since there's two of them the exact same and we're coding them inside and out, we could multiply that by 4. So 50.3 times 12.5 times 4 is 2,515, and this would be centimeters squared. Good. Let's now do the bottom, because it's another easy one. It's just a rectangle. So if we did the area for the bottom, the length of it would be 50.3, and then going this way on the bottom would be 18. 50.3 times 18. And there's only one of these, but we are going to code it top and bottom, so we would need to multiply it by 2. So 1,810.8 centimeters squared. The end caps, these two pieces, D and E, are the ones that we need to do a little bit differently because they're actually a trapezoid. So this container is kind of tapered in. Our trapezoid formula you could get from your formula sheet, and it says take half of the height. The height would be 12.5. Times B1 plus B2, so 18 plus 25. So if we're going to go half of the height times 18 plus 25. Oh, shoot. We got to multiply this by 4, right? Because we've got two of these and we're coding them inside and out. So let's not forget about multiplying it by 4. I get 1,075 centimeters squared. And we would add all those together to get our area. 2515, 1810.8, 1075. As long as I typed it into my calculator correctly, we should be here. Let me double check that I entered everything correct. It looks as if I have. So our area that we need to cover is 5,400.8 centimeters squared to rust proof that inside and out. Alright, so these last two questions are a little bit more difficult because we have to use our area formulas backwards. And first of all, we have to be able to understand what's going on with the question. So what this is saying here, if you can read through that, the airflow going into this duct would be equally distributed, not equally, but would be distributed between these two Y pieces of the duct. So the area that goes into this would be equal to the area of these added together. That way we get the same amount of airflow. All right, so our question is, how big do we need to make this piece right here? What's the diameter of this so that it will have the same area as these two put together? The only thing that we know right now are the diameters of these two Y pieces. So let's see if we can find the area of those two Y pieces. Our formula for area of a circle is pi r squared. R is the radius. This says the diameter is 10. Diameter is the whole way across the circle. We only need halfway, so the radius would only be 5. And we can use our pi key on our calculator. Pi times 5 squared. That is 78.54. We can round it because we have a little bit of tolerance, wiggle room in our answers here. And then our other piece of the Y, this one down here, diameter is 6, so the radius would be 3. So if we go pi times 3 squared, this is 28.27. Add those together. Our total amount of area would have to be 106.81 inches squared. So that means that we've added these two areas together, that this piece has to have the same amount of area. So we're going to use our formula backwards here. Our formula for area of a circle is pi r squared. We know that the area has to match our other area, so our area has to be 106.81. And we don't know what our R value is, so we got to do a little bit of algebra. We're going to try to get this R by itself, so that means that we're going to divide both sides of this equation by pi. These two pi's are going to cancel out, and we're going to be left with r squared. And if I do this on my calculator, I get 33 point, it would be 999. Okay, we can round it a little bit. Again, we have some wiggle room in our answers. The last thing we have to do is get rid of the square. And to undo a square, you would do the square root. That would be the opposite of that. So if we square root that, our radius is going to be 5.8 inches. But it's asking for the diameter. So, and it says to the nearest whole number. So we'd have to multiply this by 2 to get the diameter. It ends up being 11.66. Oh, yeah, 11.6, because I rounded it. But the nearest whole number would be 12 inches. So the diameter of that piece of the duct has to be 12 inches. So that it will keep up with the other pieces, the Y pieces of that duct. Right. This last problem is very similar to the one up above. We're going to have to do our area formulas backwards here. So we've got this boot, and it's going in, and it's going through a reducer. So the area here has to be equal to the area coming out this circular part. So the only thing that we know right now is that we know that this is a 14 by 6. So if we paper up here, 14 by 6, because it's a rectangle, right? 14 times 6, is it 84? Yes. 84 inches squared. squared. That is the area of the top here. And we know that we have to have an equal amount of area coming out the bottom. The bottom is a circle. The area formula for a circle you can get off your formula sheet. And we know that the area has to be 84. The question is, what is the radius going to be that would make that 84? So we got to divide both sides by pi. R squared is 84 divided by pi, 26.74. And the last thing that we have to do in the is to do the square root in the Pythagorean theorem. I almost said, if we do the square root of that, we get 5.17 or 5.2 inches. So the radius of this circular piece has to be 5.2. We would double that to make it the diameter. So it would be 10.4. But our question here says rounded to the nearest whole number. So we would just say that our circular part needs to have a diameter of 10 inches. Alright, sorry this video was a little bit longer, but these are very in-depth problems of how area applies to HVAC. We're actually going to be using area as we move forward because we're going to be talking about things that are called heat load calculations, and they're used so that you can pick the correct furnace or air conditioner for a room or for a house. So please submit a picture of your notes. This is the only assignment that you need to do today. All right, thank you. Hope to see you soon. Bye.